So today, we're diving into a piece of tech that could totally change the game for how we power, well, everything. We're talking fuel cells. But are they the real deal, the future of energy, or just something that sounds cool in sci-fi movies? Let's get into it.
You know, at the heart of our entire energy problem is this one really simple question. How do we make electricity without burning stuff? For centuries, that's been the go-to move, right? Burn coal, burn gas, burn oil. But what if there's another way? A cleaner, way more direct path to power. That's the exact problem fuel cells are designed to solve.
All right, so what is a fuel cell exactly? Well, before we talk about what it is, we gotta be super clear about what it isn't. And the biggest point of confusion is this: a fuel cell is not a battery. They might both give you power, but how they do it is fundamentally different. Okay, so here's the simplest way to think about it. A fuel cell is basically a tiny, super efficient power plant. It takes a fuel, hydrogen is the classic example, mixes it with oxygen from the air, and boom, you get electricity. It's a direct chemical reaction. It's like a clean shortcut to making power, no fire needed. And this right here is the key difference. A battery is kind of like a water bottle. You fill it up with energy, you use it, and then it's empty. A fuel cell, on the other hand, is like a faucet. As long as you keep the fuel, the hydrogen, flowing, it will just keep generating power, on and on. One stores energy, the other creates it on demand. So how does this whole thing work without a single spark? Well, it's all about a really clever, controlled chemical reaction. You feed hydrogen to one side, and you've got oxygen from the air on the other. In the middle, there's this special membrane that splits the hydrogen atoms. And that split is what creates a flow of electrons. And what's a flow of electrons? That's electricity. The only things that come out the other end are a little heat and pure water. That's it. No pollution, no noise. Okay, so now that we've got the basics down, let's get to the good part. Why should we be so excited about this technology? Well, that super clean and efficient process we just talked about leads to some massive advantages for our energy future. First up, let's talk efficiency. Because they convert chemical energy directly into electricity, some fuel cell systems can be over 60% efficient. Now, to put that into perspective, the internal combustion engine in your average car, it's lucky to hit 25%. That is a huge, huge leap forward.
And the benefits just keep stacking up. If you're using pure hydrogen, emissions are practically zero. And because there are no moving parts, they're almost completely silent. You can also stack them together like Legos to get more power. That's what we mean by modular and scalable. And that heat they produce, you can capture it and use it, which is something called cogeneration. It's just a really elegant, smart system.
So if these things are so great, why aren't they everywhere? Why isn't your car, your house, your everything running on a fuel cell? Well, as you might guess, there are some pretty big hurdles to get over. It's time for a little reality check. Let's just cut right to the chase. The number one thing holding fuel cells back, the single biggest challenge, is cost. Plain and simple. The materials used to make them, especially the precious metal catalysts in some types, are really expensive. The manufacturing process just isn't cheap enough yet for the mass market. And this chart really puts it into perspective, doesn't it? When you compare the cost of a fuel cell system to something like a good old internal combustion engine, it's not even close. For fuel cells to really take off, that big bar on the left has got to shrink. A lot. And you know, it's not just about the money. There are other major roadblocks. For one, where do you get the hydrogen? We don't have hydrogen filling stations on every corner. It's a classic chicken and egg problem. We also need to be sure the high-temperature units can last for years and years. And honestly, the power industry is just not used to this stuff yet. On top of that, some fuel cells are super picky about their fuel and can get poisoned by impurity.
But here's the thing, despite all those challenges, fuel cells aren't just some lab experiment. They actually have a surprisingly long and fascinating history of being used in the real world and in some of the most extreme places you can imagine.
The basic idea for the fuel cell goes all the way back to 1839. Crazy, right? But it wasn't until the 1950s that a truly practical one was built. And that breakthrough got the attention of NASA, which famously used fuel cells to provide electricity and drinking water for the Apollo missions. Since then, we've seen them in buses, submarines, and now a whole new wave of prototype cars from major manufacturers. And just think about that for a second. The Apollo space program, when failure was absolutely not an option, when astronauts' lives were on the line, NASA turned to fuel cells for power. I mean, that's a pretty powerful endorsement of just how reliable this technology can be when it's built right. So, that's the past. What about the future? Well, it's becoming pretty clear that there isn't going to be one single type of fuel cell that does everything.
It's not a one-size-fits-all solution. Instead, we're seeing different types being developed for very specific jobs.
Let's look at two of the big ones to see what I mean. You've got PEM cells, which run at low temperatures. That makes them great for things like cars, but they need really pure hydrogen and expensive platinum. On the flip side, you have SOFCs, or solid oxide fuel cells. These run super hot, which makes them perfect for stationary power plants, and they're not picky about their fuel. But they take a while to warm up, so you wouldn't want one in your car.
So, what's the big takeaway here? It's all about versatility. We're looking at a future where we have a whole toolbox of different fuel cells, each one perfectly tailored for a different job, from powering your phone to lighting up an entire city.
So we come back to that big question. Are fuel cells the key to unlocking a clean energy future? Well, the challenges are real, no doubt about it, but the potential is absolutely massive. As the technology gets better and the costs come down, we might just find that this quiet, clean source of power isn't a fantasy, but a reality. The next few years are going to be really interesting to watch. Thanks for joining me.